Welcome everyone. Today we're tackling a classic chemistry experiment, the titration of potassium permanganate versus oxalic acid. Now, I know it can look kind of like a magic trick, but it's all about pure science, precision, and really understanding what's happening in that flask.
So, here's the big question, right? How do you figure out the strength of something when you can't just look at it and know? Well, the answer lies in a really powerful technique.
And that technique is called titration. It's a way to use a solution you know the concentration of to figure out one that you don't. Today, we're going to walk through exactly how to do this one, step by step, so you can get it right every time. Okay, first things first. Before you even think about measuring a chemical, you've got to get your equipment ready. I'm telling you, the foundation of a good titration is perfectly prepped glassware. This is where it all begins. So, we've got three main players on our team today: a burette, a pipette, and a conical flask. And each one has its own little prep ritual to make sure our final results are totally spot on.
Now, hold on a second. Take a look at step 2. Why in the world would you rinse the burette with the actual chemical you're about to use? Doesn't that seem a little backward?
Well, there's a brilliant reason why. Rinsing with the potassium permanganate, or KMnO4, gets rid of any little water droplets left over from washing. See, if you didn't, that water would dilute your solution just a tiny bit, and poof, your final result would be wrong. It's all about precision.
So, you might be thinking, okay, but what about the pipette and the flask? For these, just a simple water wash is perfect. Why? Because we're about to add a very specific amount of oxalic acid to them. Any leftover water in there won't change the total amount of acid we're measuring. All right, our glassware is ready to go. Time for the chemicals.
Let's move on to the next phase, getting our oxalic acid solution ready. We're basically setting the stage for the main event, which is the chemical reaction itself.
That sulfuric acid is absolutely essential. The reaction just won't work properly without an acidic environment. Think of it as the secret ingredient that gets everything going. But wait, there's one more critical thing we have to do.
You see, at room temperature, this reaction is super slow, like watching paint dry slow. So to speed things up, we need to give it a little energy boost by gently heating the mixture to somewhere between 60 and 70 degrees Celsius.
Now be really careful here. You don't want to boil it. If you do, some of the acid might break down, and that'll mess up your results. The perfect visual cue to stop heating is when you see those little water vapors, that condensation, forming on the inside neck of the flask. That's your signal that you're in the sweet spot.
Okay, our setup is ready, the solution is heated, it's showtime. We're ready to start the actual titration. This is really the heart of the whole experiment.
First things first, you've got to know where you're starting from. So we take a look at our burette and record that initial reading. For this run, we're kicking things off at 13.5 milliliters.
So here's where the technique really matters. We start out adding the purple KMnO4 solution really slowly, like drop by drop. But then, as the reaction gets going, you'll notice you can actually speed up and add it in a faster flow. What's up with that?
Yeah, what's happening in that flask that lets us go from a super cautious crawl to a nice steady flow? The answer is probably the coolest part of this entire reaction.
This is just fascinating. One of the products of the reaction, this thing called the manganese ion, or Mn2+, actually acts as a catalyst for the reaction itself. It's a process called autocatalysis. The reaction literally creates its own accelerator. Once you've made a little bit of it, the whole thing just takes off. How cool is that?
All right, we're getting close now. We're approaching the most important moment of the whole titration, spotting that exact point when the reaction is officially complete.
You're looking for something very specific here. It's the very first, faintest hint of pink that stays in the solution even after you swirl it. See, as long as there's oxalic acid left, the purple KMnO4 turns colorless instantly. But the very first drop that has no more acid to react with will keep its color, turning the whole solution a pale pink. That's your signal to stop.
And the second you see that persistent pink color, bam! You shut off the burette and immediately take your final reading. In our case, we've landed at exactly 32.0 milliliters.
Now look, in science, doing something just once is almost never enough. To get a result you can really trust, you have to repeat the whole process a few times. You're looking for at least 2 readings that are super close to each other. We call those concordant values. Averaging those gives you the accurate number you need for your final calculation.
So we've gone through the how of this whole procedure. But as you've seen, it's really understanding the why you rinse the burette a certain way, why you heat the solution, that amazing autocatalysis. That's what takes you from just following steps to really understanding the chemistry.